Hey guys, welcome. This is part 2. We're going to finish it up. Here we go. Alright, number 42. So f of x. So right here, f of x is really the same as y. So it's kind of the same thing. So f of x is the same as y. So when we look here, it says f of negative 1. So this plugs in for x. So I'm asking what's the associated y. So negative 1, I look up and we see 1 right there. So we get a value of 1. F of 2, so when I plug in 2 for x, what do I get for my y? I get 3. Now f of x equals negative 1, so this is basically saying what is x when y equals negative 1. So I go to y equals negative 1, I go over and I see x is 1. State the domain and range, and is it a function? So a function, again, for every x, we only have one y. And we could do the vertical line test. We see that it does not hit more than once, so this is a function, yes. My domain is my x values, so my range goes from negative 4 all the way to 2. We're going to put that in brackets because we include that. And then my range is going from negative 1 all the way up to 4. And those are also in brackets because we have solid points. And there we go. That was y. Okay, so write the equation in slope-intercept form. So here we just have to solve for y, get y alone, and that should put us into slope-intercept form. So we're going to subtract the 3x on both sides. So we get 5y equals negative 3x plus 10, and then we just divide everything by 5. Once you do that, the y gets alone. You get negative 3 over 5x, which is a fraction. It's okay because slopes are usually fractions with rise over run, and then 10 divided by 5 is a positive 2. And that's slope-intercept form. Again, y equals mx plus b. And from here, we can pull out my y-intercept at 2 and my slope of negative 3 over 5 if I need it. Find the slope between the 2 points. The slope formula is y2 minus y1 over x2 minus x1. And so I like to label my points. And sometimes you just set up the equation with that negative built in right there, and then I plug things in. So y2 is 0 minus y1, which is 3. x2 is negative 3 minus x1, which is 3. And so we get negative 3 over, and then those two are negative, so we get negative 6. Now they're both negative, so it's going to come out positive, and we reduce to 1/2. And that's my slope. So same thing, find the slope again. Again, we can set up the equation like this. Label my points. Plug in y2 minus y1, x2 minus x1. 2 minus 2 is 0, and negative 3. So since the top is 0, it's just 0, so my slope is 0. If 0 is on the bottom, we'd call that undefined. Alright, find the slope of the linear function. So here again, rise over run, so we can just count. So I can go down from this to negative 6, so I go down to negative 6, and then I go over from negative 4 to positive 4, 8. So if it was rise over run, I went down 6 and I ran 8. And then we can reduce that by dividing by 2. To get negative 3 over 4 as my slope. So this one right here, this would be a good thing to add to your note card, but this is a y equals line, so y equals line are always horizontal, which means they have a 0 slope. So our slope for this is 0. And then right next to it, the one below it, we have an x equals line, and these always have an undefined slope. Alright, we're making our way. Making our way downtown, moving fast. I don't remember the rest of the lyrics, but there we go. That was Vanessa Carlson, I think. Pretty sure. Alright. Find the slope and the y-intercept. To do that, probably best to put into slope-intercept form. So I'm going to subtract the 12x. And we got 4y equals negative 12x plus 4. And divide everything by 4. Get y equals, That should reduce. 4 goes into that 3 times, so we get negative 3x, and then 4 goes into that once. So my slope is negative 3 over 1, and my y-intercept is 1. And there we go. Find the x and the y-intercept. So remember, for the x-intercept, we want y equal to 0, and for the y-intercept, we want x equal to 0. So if we plug in 0 for x, we get our y-intercept. So 2 times 0 minus 6y equals negative 18. That essentially goes away. Divide by negative 6, and y equals 3. So my y-intercept is 3. My x value is 0, so I'd write it as 0, 3. For my x-intercept, I get 2x minus 6. Plug in 0 for y. That goes away, so I get 2x equals negative 18. Divide by 2x equals negative 9, so I get negative 9, 0. So again, a lot faster to do it where you just plug in 0 for those values to find it. All right, that was a fast page. How many do we have left? 1, 2, 3, 4. 4 pages. We got this. Easy. All right, find the x and y intercepts. This one's easy. We just literally look on it. My y intercept here is at negative 4. That's 0 on the x, negative 4 on the y, and this is at 2. That's 2 on the x, 0 on the y. Boom. Write the equation of the horizontal line that passes through the point 2, 5. Easiest way to do this is to draw a little graph, find 2, 5, and then draw a horizontal line. There it is. Now remember, on the page previous, we said if it's a horizontal line, it's a y equals line. So this is going to be a y equals line. And where does it going through on the y? 5. So that's y equals 5. The next one, same thing. Graph the point. That's at negative 3, 4. And this is a undefined slope, which we know is an x equals line. So we're going to get x equals. And what does x equal? Negative 3. There you go. So again, good thing to remember, y equals are 0 slopes that are horizontal, x equals are undefined slopes that are vertical. All right, write the equation of a line with a slope that passes through a point. So we got to use point slope form. So I'm going to write it once, and we'll use this for probably a couple problems. And we'll label this x1, y1. So we get y minus a negative 3 equals negative 1/3 x minus 9. Okay, so 2 negatives make that a positive over there. We're going to distribute this, so I get negative 1/3 x, and then negative 1/3 of negative 9 becomes a positive 3. And then when I subtract 3, it cancels out over here, but it will cancel here too. So I end up with y equals negative 1/3 x. I can write plus 0 if I want, so the y-intercept is at 0, 0 technically, but I don't have to write that. Alright, so for the next two problems, these are kind of the longer ones, where we have to find the slope first using slope formula, and then use point slope like we just did on this last one. So, buckle in, let's get started. Okay, so I wrote the formula for this already earlier, y2 minus y1, so I'm not going to write it again. Again, to set this up, 4 and 5, we get negative 6 over negative 1, which is just going to be 6 as my slope. Okay, from here we basically have the same problem. So I'm going to plug into that formula with a pink pen. So y minus y1 equals my slope 6, and then x minus x1. And I'm using the same point, x1, y1. I could use x2, y2, but I chose to use x1, y1. Distribute, we get 6x minus 30, and then add 3. So we get y equals 6x minus 30 plus 3 is going to be negative 27. So again, same thing. Next one. x1, y1, x2, y2. Put that negative in already, so we get negative 7 minus 7, 2, minus 4. So we get negative 14 over negative 2, which just gives me 7 as my slope. And then we plug it into formula, so it's going to be y minus 7 equals 7 times x minus 4. Distribute, and I'm going to bring it over here, we have 7x minus 28, add the 7, and we should get y equals 7x, negative 28 plus 7 is a negative 21. Boom. Okay, so again, a little lengthy, but we use slope formula to find the slope. Then with the point in the slope, we put it into point slope. Alrighty. Ooh, fill in the blanks. I'm good at these. Parallel lines have the same slope and different y-intercept. Okay, if they have the same intercept, they'd be the same line. Perpendicular lines have the, well, words right there, opposite reciprocal slope. What's the opposite reciprocal of? I'm assuming there was supposed to be something there and I don't see it, so that's kind of a weird one. So let's just do 1/2, and then it would be negative 2. That was weird. Alright, write the equation of a line that is parallel to and passes through a point. So if it's parallel, it's the same slope. So I just grab this and I put it into point slope form. And here we go. So we get y minus 3 equals negative 3. There's the slope I got from there. X minus 5. Distribute, we get negative 3x plus 15. And then we add 3. And we get y equals negative 3x plus 18. Write the equation line that's parallel to and passes through. So same thing, we're just taking the same exact slope, 1/2, and a point, and putting it into point slope. So y minus 1 equals 1/2 of x minus a negative 12. That becomes positive. We get 1/2 x, and half of 12 is 6. And then I add 1 to get y equals 1/2 x plus 7. Alright, for the next two, it looks like we're getting perpendicular. So for perpendicular, we just got to make sure we do the opposite reciprocal slope. So instead of 1/3, we're going to get negative 3 for our slope. And instead of 2, we're going to get negative 1/2. So it's the opposite sign, and we flip it. Okay, and then from there, it's pretty much the same. So y minus 3 equals negative 3x minus minus 3. Those become positive. We distribute, we get negative 3x minus 9. Add the 3. We get y equals negative 3x minus 6. And with 1/2, we get y minus 6 equals negative 1/2 x minus a negative 4. Those become positive, and we get y minus 6 equals negative 1/2 x minus 2, and then add the 6. And that becomes plus 4. Alright, 2 more. Ooh. Alright, the equation of the line in slope-intercept form, so we just got to find the slope, which is up 1, 2, 3 over 1. And my y-intercept is 2. So we get y equals m x plus b. 3 over 1x plus 2, or you can just write 3. Without graphing, tell if this point is a solution. So all I have to do is plug it in to see if it's a solution. So this is my x and my y. So that first one, I'm going to get 3 times negative 1 plus 4 equals 1. So negative 3 plus 4 equals 1. 1 equals 1. That's true. Over here, I'm going to get 4 equals negative 2 times negative 1 minus 4. That's going to be 2 minus 4, which is negative 2. That does not equal 4, so the answer is no solution. That does not work. Solve by graphing. So first one I can graph is at 4, and my slope is up 2 over 1, up 2 over 1, or down 2, back 1, down 2, back 1. And then in this one, we got to solve for it. So I'm going to subtract the 3x, and then divide by negative 5. So we get 3 over 5x minus 3. So I start at negative 3. I'm going to go up 3. 1, 2, 3 over 1, 2, 3, 4, 5. I'm going to go down 1, 2, 3, back 1, 2, 3, 4, 5. I'm guessing it's probably going to be that point right there, if I have to guess. down 2 over 1, down 2 over 1, down 2 over 1. Yeah, so it's going to be right here at -5, -6. That is where they meet. Solve by substitution, so I'm going to take this guy and plug it in for y. So I get 6x plus 2. Then I sub in what y equals, and then we distribute. So 6x minus 6x plus 10 equals 8. Now here the 6x's cancel out and I get 10 equals 8, which is not true. So this is a situation where we get no solution. Basically, we probably have lines that are parallel. They're never meeting. So that's kind of what's happening on that one. On the next one, substitution, we're going to sub in for x this time. So we get 3 minus 5y equals 15. I'm going to substitute what x equals in here as 4y plus 12. So we distribute, we get 12y plus 36 minus 5y equals 15. Combine like terms, that's going to give me 7y. And subtract the 36 right there. And we get 15 minus 36 is -21. Divide by 7, we get -3. And I plug that into any of the equations. I'm going to plug it to this one, so x equals 4 times -3 plus 12. That's going to be -12 plus 12, so x equals 0. So we get 0, -3 as where they meet. Alright, last two, we made it. So for elimination, we want to make sure things line up. So I'm going to pick to multiply this by 3, that will give me 15. And if I multiply this bottom one by 5, that will give me -15. So those should cancel. So I'm going to rewrite them over here, red for the first one. So I get 12x, multiply everything by 3. 15y equals 66. The next one is going to be 5 times 7 is 35x minus 15y equals, and check that one, 160. Okay, so we're going to combine those. So that's going to give me 47x. That goes to nothing. And then we're going to get -94. Divide that by 47. X equals -2. And I just plug it into any of these. I'm going to plug it to the top one. So that's going to be -8 plus 5y. I'm going to add the 8 over. So we get 5y equals 30. And then divide by 5, and y equals 6. So you get -2, 6. And last one here, I'm just going to multiply the bottom one by -3. So I get 3x plus 6y equals 27. That's the top equation. The bottom one's going to become -3x, -6y, and -33. So when I combine these cancel, so I get 0 equals, and that becomes -6. That's not true, so no solution. Alright, there it is. Good luck, and goodbye.